Okay, this is chapter 1, page 6, and I'll go over a few things on this page and the next one. Okay, so when we have a decision problem, it's going to have three main features. One, there will be options or acts. Second, there will be outcomes, and the author has an example here to illustrate these. And then third, there will be states of the environment, or just states. And when we have a decision problem, often or typically, we want to set it up in a decision table, like this one here. Okay, so we'll do that. We'll look at this decision problem here. We'll identify the options, states, and outcomes, and we'll create a decision table. Okay, so after a hard day at MSU, you decide to go to the racetrack. By the time you arrive, there's only one race left. 3 horses are racing, and you are going to bet on which one will win. The horses are Sloppy Stan, Wobbly Pete, and Dave. Okay, so you're going to bet, so that means that you have an option to bet on each one of these horses. Those are your options, and one of them is going to win. So Sloppy Stan winning, Wobbly Pete winning, or Dave winning are going to be our states. And then if you pick either Sloppy Stan or Wobbly Pete, and that horse finishes first, you get $10. So that's one outcome. Otherwise, you lose $4. That's another outcome. If you pick Dave and Sloppy Stan finishes first, you lose 12. That's an outcome. If you pick Dave and Wobbly Pete finishes first, you get 5. If you pick Dave and he finishes first, you get 10. Okay, so let's create a table. Let's see, what's our order here? Stan, Pete, and Dave. Okay, so these are the options. Our states are going to go over here, and they are okay. And then let's see, what do we have? You pick either Sloppy Stan or Wobbly Pete, and that horse finishes first. You get $10. Otherwise, you lose 4. So we'll put 10 here, here. Okay, bet on Dave. If you pick Dave and Sloppy Stan finishes first, you lose 12. If you pick Dave and Wobbly Pete finishes first, you get 5. And if you pick Dave and he finishes first, you get 10. Okay, so then these 9 options are, well, they're not options, they're 9 possibilities, are the outcomes. Possible outcomes. All right, here's a second one. It's summer break and you are staying at your parents' house. One Saturday night, your grandmother, who lives 2 states over, calls and says that she is coming to visit. She will arrive either Sunday afternoon or Wednesday afternoon. She isn't sure which. Now it is Sunday morning. Your parents have asked you to mow the lawn before your grandmother arrives. You agree that mowing the lawn before she arrives is a good idea. but you really don't feel like doing it this morning. You'd rather just sit in front of the TV and mow it on Tuesday. Okay, so in this case, there are two options. And there are two states. So if you sit in front of the TV and she arrives on Sunday, then the lawn is not mowed when she arrives. If you mow the lawn and your grandmother arrives on Sunday, then, that is, if you mow it on Sunday, then the lawn is mowed when she arrives. Okay, if you sit in front of the TV, let's see, this is and mow on Tuesday, then when your grandmother arrives on Wednesday, the lawn is mowed. And if you just mow it on Sunday morning and your grandmother arrives on Wednesday, again, the lawn is mowed. Okay, so options. States, and then these are the outcomes. Okay, and one more. A jar contains 100 marbles, and one marble is about to be selected at random from this jar. 30 of the marbles are red, 60 of them are blue, and 10 are green. You are given three choices: bet on red, bet on blue, or bet on green. Okay, so those are the options. Okay, and the states are going to be a red marble is drawn, a blue marble is drawn, or a green marble is drawn. Okay, if you bet on red and a red marble is drawn, you get $12. If red isn't drawn and you bet on red, you lose 6. If you bet on blue and blue is drawn, you get 5. If blue isn't drawn, you lose 5. Oops. Okay, -5, 5, and -5. Let's see. If you bet on green and green is drawn, you get 9. If blue is drawn, you'll get 5. Okay, it's a +5 there. And if red is drawn, you lose 15. Okay. All right, now you'll notice in this problem, we have some additional information. Namely, we know that there are 100 marbles in the jar, and we know that 30 of them are red, 60 are blue, and 10 are green. So if a marble is going to be randomly selected from this jar, then we also know that the probability of a red marble being drawn is 30%. Probability of a blue marble being drawn is 60%. And the probability of a green marble being drawn is 10%. Do I have that right? Yes. Okay, so that's additional information that we're going to want to use if we're making a decision. And so we'll include it in our table as well. All right, now back to the chapter for a second. So went over that. Okay, there also are these two terms here, mutually exclusive and exhaustive. The author sort of explains what they mean right here, but you should look at the notes where I've defined them. And there's also on these pages the dominance principle, but I'll go over that in the next video.